Okay, we're recording again here, video number 2 on the 10 magnet rotor 5 drive coil system. Still running, and we're at about 27.5 milliamps, so 12.9 volts. So we're pretty darn close to about 300 milliwatts. Okay, so this video is going to be adding the helper magnets to demonstrate what this is going to do. Now, as you can see, the tops of these coil holders have been cut off. When I first saw them, this is the first time I've used them, you know, with the new rig here. Since I got back to Alberta here and got this motor back up and running and started working on it again. I couldn't figure out for the life of me why I cut these things and drilled them like that, but I think now I understand, because it's in order to be able to get the magnets right against the cores, the coils themselves. So you see, I just added a helper magnet. The current went up, kind of jumped quite a bit there, almost to 10 milliamps, but as you can see, over time it will settle back down somewhat. You can also hear that the motor had increased in its speed, so I'm going to add another one over here. Speed increase again, current jump again, voltage down somewhat. But as I've explained numerous times before, this thing will settle out and stabilize at a certain operational level. We're going to add another one. We got 3 on there now. We're going to add the 4th one. Right beside the Hall probe, even more speed. Current's jumped up quite a lot. The voltage has come down as a result, and we've got one more helper magnet, which is not in a tube for obvious reasons, because of this last tower here has not been trimmed down to resemble the other one, which is going to happen soon. But anyways, we got the last one on there. It's not quite the same as what the other ones are. It's somewhat removed from the actual core. I'm sure it would perform better if I had trimmed that properly the way the other ones are. I've got a drill press and the tools now to start cutting some new towers and whatnot, because I'm going to need them. So now we're going to take a RPM measurement here. Our current's up to, what was it, at 30 before? We're at 74, so we've added about 44 milliamps. Our voltage has dropped to about 12.4. Now I'm going to take a RPM reading here. Switch hands with the camera here. Let's get this in the light so you can see. And we can see that we've jumped quite considerably in RPMs. And it's going to keep going, of course. It takes time for this thing to wind itself up and stabilize. So I'm going to kind of say that, you know, this one's going to maybe stabilize out at about just under 2,800 RPMs. So that's that. I've got the damn boom here that's in my way. That's why I'm kind of working my way around here. Oh, and I'm zoomed in here. I shouldn't be. There. Okay, that's better. Oh no, I was not zoomed in. Okay. Now, what we can do now is adjust this. God damn it. Adjust this Hall sensor here. I've got my hand in there. I said in the first video, this is a brand new puppy. It's not behaving anything like the earlier versions. It's got quite different characteristics here. I can hook the load up here, the lights that I normally run here, and our speed increases and our current drops. Now, why does that do that? Oh, it's stabilized back up again, but you can hear, oh, no, it's coming down, speed's going up. Now, the other thing, too, I wanted to mention as well is that this steering diode business is not behaving the way it used to either. When I put a drag on the spindle here with my hand, our current doesn't go down, it goes up, which is to be expected from normal motors. So that's another change that's happened with this particular geometry. So I'm guessing my idea with incorporating what is considered or called oppositional harmonics and removing them with this type of geometry is not conducive to say improving the performance and getting the same results that we were getting before. Again, I'm using the wrong type of capacitor. This has a half meg ohm resistor, internal resistance to it. It's a microwave oven or a high pressure sodium HID ballast capacitor, which is not what we should be using. I'm going to be getting some capacitors soon in the mail here pretty quick from a fellow researcher inventor. But as you can see, our current has kind of settled down below what it was running at before we connected the load. So there again, 74 to 64, we've dropped 10 milliamps by adding a load onto the secondary coils. This should not happen. We still haven't figured out why it's doing this. Personally, I don't really care if I never figure it out, as long as it just works. Okay, this one's gone on a little bit longer than I wanted to. So, next step, we're going to rewire this puppy to go full bifilar mode, and we'll see you shortly.